Welcome, Math 30-2. I'm just going to go into the next lesson here, dealing with equivalent rational expressions. First thing we need to understand is equivalent rational expressions are basically dealing with this whole fact of, well, when you have a rational number like 10 over 15, what do we do with it? How do you know it's equivalent? You always have to ask yourself, if you could do the same thing on the top of the fraction and the same thing on the bottom of the fraction with the multiplication or dividing, you can actually come up with an equivalent rational expression. So example here is dealing with, well, 10 over 15. If you divide the numerator and denominator by 5, you will be realizing that 10 over 15 can be reduced to 2 over 3. So determine a second equivalent expression, that's 10 over 15, that has the same process above. Well, how about multiplying, as I said? Well, if we multiply by 2, then the top and the bottom, you will be getting 20 over 30. So there is many forms of equivalent rational expressions. So what's next is that we can also show this in a fraction form, in factor form, I should say. In the factor form, what could happen is that you would have 10 over 15, then you could say to yourself, well, 5 and 2 could go in it, and 5 and 3 could go in it. The 5s could cross out, bang, bang, and what's left over, 2 over 3. So moving on with this concept, I want you to try this investigation, which before we do the investigation is a class example which determines equivalent forms of 18 over 42. So if you're dividing numerator and denominator, what would be the common denominator and numerator you would use? Well, something's in the times table that fits both of them. That is correct, 6. So you should be dividing by 6. So if you do that, you will realize it could be brought down to 3 over 7. While multiplying numerator and denominator, you can multiply anything and try to stay with 1 because it's going to be the exact same answer. Then it's not showing it's the equivalent. So try 2, 3, 4, whatever. 2 is the best one to use because it's very straightforward to know how to multiply by 2. So if you do that, of course, 18 times 2 is 36. 42 times 2 is 84, and that's where that's coming from. Factor and dividing factors. This is where you're going to have to take out what's common at the top and what's on the bottom and cross them out. Hence the fact you get the following. The 6 is common, cross out, that's left over 3 and the 7. Write a different answer for each part in part A, so you can do many things. I'm going to show you 3 different ones right here, and you're going to realize 16 over 14, so what happened there? You should think through it. How did that happen? Same thing for 180 over 420, and then 9 over 21. There's many answers for that. So I would like you to try the following a couple pages after that's dealing with question 1 and 3. Moving on, try this investigation where it's basically on page 426, where it's dealing with this whole fact, trying to understand rational expressions. So you realize you have 2 rational expressions here, the left hand and the right one. So if you can actually do the same operations with the left one and the right fraction, and if they come out to be the same, then you got yourself the beautiful, well, the fact that they're equivalent. So this is what this investigation is trying to get at. Same thing, always remember that there are usually things to note. The big note here is that when you have these 2 fractions, see if you can have them in the lowest term or simplest term. So if you can simplify it any further, then you are not simplified. So if you can, by crossing out the top and the bottom, then you're set to go. So keep in mind, you always want to reduce fractions as much as possible. So here's another investigation on 427 in this case. Try it because it's now investigating non-permissible values and especially restrictions and equivalent forms. So here are the answers for that. So keep in mind, non-permissible values and restrictions are essential because it deals with the fact that you can't have a denominator with 0. If you do, it doesn't exist. Hence the fact we want to stress that. Another thing is that you always want to look for non-permissible values right before you start simplifying, especially when you cross out. You could simplify in the sense of, oh yeah, I see what's common at the top and the bottom. Don't cross them out just yet. Find the NPVs first, then you're good to go. So let's try example 2, which is at the top of 428, where it's saying write an equivalent form of the rational expression 8x over 6x minus 4. I could see right off the back, all 3 of those terms, one first term on top, the 2 terms on the bottom, are multiples of 2. So dividing numerator and denominator, I'm going to divide by 2, and then you're going to be finding that I'm going to have 4x over 3x minus 2, because I divided everything by 2. Multiplying numerator and denominator, same thing. If I multiply by 2, what's going to end up happening is you're going to do 8x times 2. 6x times 2, negative 4 times 2. So hence the fact you get 16x, 12x minus 8. But the beauty is if you could show this in factoring form. If you show it in factoring form, what ends up happening is that you can actually see where they cross out. You could even include the NPVs, easier view of it. So if you take out a 2 at the top and the bottom, what's going to end up happening is that you cross them out. You have the 4x in the bracket. You have the 3x minus 2 in the bracket. And that is your final answer. But you need to include the NPVs. Don't forget that. And the NPV is the dealing with the denominator. So 3x minus 2 equal to 0. So from there, add 2 on both sides. You get 2 over 3. That's your NPV for that. So now the next class, example 3, in the middle of that page, you're going to be realizing, right, which of the following are equivalent forms of the rational expression? 6 over 2x minus 1. So you could do many things. Multiply numerator and denominator, divide by numerator and denominator. If it doesn't work out nicely, it's one of the first steps you do, then you know it's not equivalent. So 12 over 4x minus 1. I have a good feeling it's not because of the 1. The 1 is still the same at the bottom right-hand corner of that fraction. So if we multiply 2 over 2, so meaning that I multiply 2 on the top, 2 on the bottom, you're going to get 24, of course, and then 4x minus 2, so that's giving 24. So what's going to end up happening there is it's not equivalent because it's not the same. So the same thing as negative 18 over 3 minus 6x. Well, I can multiply negative 3 to get rid of that negative, of course, to see if you come up with the same thing. What's going to end up happening is that you get negative 18 over 3 minus 6x, and what ends up happening, is that equivalent? Well, you bet it is. So that's the beauty of that one, because if you times it by 3, the top one, which we did, and you times the bottom by 3, you're going to be realizing it comes the same, and that's the beauty of this. So how do we go from 6x squared, 2x cubed, and minus x? You multiply by x squared and x squared. So if we do that, do we actually get that from doing 6 times x squared and 2x times x squared and 1 minus x squared? Unfortunately not. So hence the fact that's no. So we'll try the last one here. It's dealing with divide by 2 and divide by 2 because we want to get from 3x minus 1. Well, unfortunately, it's not going to work out again because you get 1 over 2 as that fraction on the right-hand side. Hence the fact it's no. One last class example here. It's dealing with John. Evaluate each expression for x is not equal to 0. So right off the bat, he's saying that you can't have x as one of the solutions here. Based on his answers, he concluded that the rational expressions are equivalent. Well, comment on his conclusion. Is he right? Well, try with 0. So he did try with 0, and hence that the left rational expression and the right rational expression are equivalent. So yay! What happens if you use a different number, like 1? So in that sense, if you used 1, what ends up happening is that it doesn't. The left rational expression becomes 4. The right rational expression becomes 8 over 3. Unfortunately, they're not equivalent. That's the thing. John did actually include 0 as one of his solutions by substituting, but unfortunately it does not equivalent. So you got to try other numbers to make sure that is equivalent. Hence the fact that's what it says right there. So now your goal is trying the rest of the practice problems that are found on your next page there, 4 through 10. Any questions? Don't ever hesitate to let me know. Have a great day.